not all substitutions are extremely straightforward. Sometimes you have to be a little bit clever with how you do it. So in the case of x times the square root of x plus 9 dx, the integral of that, standard thing, okay, right, trying direct substitution is not going to work. So let's try to do a u sub. Okay, well, typically you pick the thing inside of the square root or a parentheses or something like that. So I'm going to say let u equal x plus 9. So then what I'm going to, the normal process says I need to take the derivative of, and du, well, that's 1, so 1 dx. So du is equal to dx, and that's great. So then what I'm going to do is I'm going to try to plug in this to here. And what I get is x square root of u du. But I have this x here. But I have d equals dx and x plus 9 is u, but I don't have anything that's just going to let me naturally just solve this. So what I need to do is I need to use the fact that I have this relationship. So if u is x plus 9, that tells me that specifically x is actually u minus 9. Okay, like subtracting x from both sides. So that's the relationship they have. So that means that this is actually u minus 9 square root of u du. Okay. Now we can use this to solve our problem. If we distribute this square root of u to both terms, I'd end up with u to the 3 halves minus 9 u to the 1 half du. Right, because that's u to the 1 half. So 1 half plus 1 is 3 halves, and then those just combine. So once I have it as in this form, I can do the power rule, which gives me u to the 5 halves over 5 halves minus 9 u to the 3 halves over 3 halves plus a constant. Now this is pretty ugly, so let's figure that out. This is going to be 2/5 u to the 5 halves minus, so multiplying by the reciprocal, 2/3, that becomes 18/3 or 6 u to the 3 halves plus c. And then we go back to the original to say 2/5 x plus 9 to the 5 halves minus 6 x plus 9 to the 3 halves plus c. And there's a way you could further simplify this. This is perfectly acceptable for my purposes, but you could say, all right, well, it's got a 2 in common, and it's got an x plus 9 to the 3 halves in common, so that leaves 1/5 x plus 9/5 minus 3. And then you could pull that out to get 2/5 I think this is correct. Now this is kind of overkill. The reason why I think this is usually better is because A, it's going to make your life a lot easier when you take those derivatives to verify that you get this. But I mean, it is what it is. You know, you can. This is probably also an acceptable answer, but I would just do that. You know, just honestly, it doesn't really matter.